So welcome to our workshop, TYMIQ Workshop, and today we'll talk about Kubernetes. We had already some Kubernetes session before, but today Andrei Kalach, platform architect on Conrad, I have quite a long experience with some complex aspects of the Kubernetes. It will shed a light on some topics like resource management, type of deployments, affinities, and so on. So I will hand on to Andrei.
Yeah, hello everyone. Let me share the presentation. Yeah, great. Yeah, so let's begin with a short introduction. My name is Andrei Kalach. I'm platform architect at Conrad Electronics. My professional focus is Java Spring for software development, Kubernetes for running applications, and PostgreSQL Kafka as data backend. Couple of words and numbers about Conrad. It's a multinational European retailer of electronic products, parts. Headquarters is based in Germany. So I'm working in team responsible for product catalog. And just to name a number, we have 9 million products in our catalog and 210 million shop visits per year. As you can guess, we are using Java for developing our services, and we are running this application on Kubernetes. So the agenda for today is we will talk about resource configuration and best practices, pitfalls, and some highlights about possible deployment types, and at the end about resilience, maintenance, scaling. So let's begin with resource management. So the smallest deployment unit in Kubernetes is a pod. A pod is actually a set of containers. It can be only a single container, but you can deploy several containers in one pod. And for each container, you can define a block with resources. This block is actually optional, so you can deploy it without defining resources, but some Kubernetes cluster operators are enforcing it, so you as developer must define some values for resources. And there are good reasons why this is required. So let's take a look. The first reason is if you are defining resources for our containers, we are allowing Kubernetes scheduler to find a better node for execution of our application. So I have prepared really simple diagram how a Kubernetes cluster looks like, and it consists of one or multiple worker nodes and a control plane. So control plane is kind of brain, how the cluster is responsible for orchestration and management. And one of the responsibilities of the control plane is to put your pod on a worker node. And if you define the amount of computer power you expect your application needs, how many CPU and RAM you need, the control plane can choose most suitable worker node for you. Because as I try to represent here, you can have different worker nodes. They can have different amount of CPUs and RAM. And Kubernetes is a dynamic environment, and the load on a particular node can be different. So if you're providing our expected resource consumption, control plane can choose accordingly a proper node for us. And the important point here is that this information we are giving to control plane, so how many resources we are requesting, it's not only for the initial phase for the deployment or for the scheduling, it is guaranteed by Kubernetes. So if it has accepted our pod and has scheduled it on some worker node, it guarantees that for all the lifetime of the pod, we will have this computer power. And this is the second reason why it is important to set requests and limits for your application to deploy. So it can happen that on a particular node, the amount of allocated memory is approaching a limit, some threshold, with this guarantee of requested memory for pods running on this node cannot be guaranteed anymore. Yeah. And in this case, so in terms of Kubernetes, it's named node pressure. And in this case, the Kubernetes agent running on a node named kubelet will start a process for evicting some application running on node to reduce the pressure, to give back again this guarantee to all other applications. So in human words, we can say it's a noisy neighbor situation. So when one application consumes so much that it affects or can affect the performance of other applications, right? And how it works, this eviction process, the kubelet first takes all pods which have neither requests nor limits and evicts them. If it's not enough, it will take pods which have request sets but no limits, or request sets but with limits, but limits are higher than requests, and will evict some of them. So this means that if your application, if you deploy your application and you properly set requests and limits, and they have the same values, it's a called guaranteed quality of service. So your application will be never actually evicted from a node. So it gives you additional security or robustness. Okay. Then, okay, node pressure, it's one situation which can happen. Another situation, even if we have enough compute resources on our node, it can still happen that the application running in pod will try to allocate more resources than allowed by limit. And then there is a protection mechanism for it as well. So it behaves a bit different for memory and for CPU. So in case if we will try to allocate more memory than we have defined it in limit, our container will be restarted. So actually, your application will be started again on the same node, and if you have proper monitoring, you will get an alert, and you will understand, okay, possibly I configured not enough memory for it. With CPU, it's a bit different. So if our application tries to consume more CPU than we have configured in our limits, so what kubelet does, it slows down the application. So this effect is named throttling. And let's take a deeper look at it, because it's not so trivial to understand. Because if we are defining in request or limit one CPU, it does not mean that we are assigning a physical CPU core to our process. So if you are running on 16 CPU core host, we still have access to all these cores, actually. So we can run multiple threads on multiple cores. So what we are defining in requests and limits is a quota, a CPU quota. So Kubernetes uses Linux kernel scheduler, it's named CFS. And when we are defining limits on our containers, it translates to CFS quota. And to explain it in simple words, this quota is actually 100 millisecond amount of time. Yeah, and if we are saying we have one CPU, it translates to 100 millisecond access to CPU cycles. If we are setting 2 CPU, it will mean we will have 200 milliseconds of CPU cycles time. Again, we have multiple cores, so this time can be spread over multiple cores. So it's important to mention that as we are working not with physical cores, but with quota, we can configure fractional values. So we can say 0.1 CPU, or its equivalent of 100 mH milli-CPU. Yeah, and then yeah, I mentioned already this process that application can be slowed down, can be throttled, and it occurs because we have multiple cores and we have in a Java application multiple threads almost always. So I have prepared a short example to demonstrate how it works. So I got exactly this period of time, 100 milliseconds, and let's suppose we have simple Java application, Tomcat serving some HTTP request. Normally, it's the latency is 40 milliseconds. We are quite confident it's always 40 milliseconds. And then we got request number 1. has been processed in 40 milliseconds. A bit later, we got request number 2. Everything fine again, 40 milliseconds. And here at that moment, we already consumed 80 milliseconds of our quota in 50 milliseconds, so in half of our quota period. So let's suppose we got request number 3, and we are expecting as developer, okay, we should get the response in 40 milliseconds again, but after 20 milliseconds of processing, it's somewhere here, yeah, our quota is over, and the throttling is happening. So what does it mean? That we need to wait all this period until the end of the CFS quota time interval, and only when the next period starts, we will get the quota again. So I get here some simple calculation. So instead of expected response time of 40 milliseconds, we will get the response time in 80 milliseconds, so twice it's long. And it's really, it can be really painful debugging. If you have under provisioning your application and you have assigned not enough CPU, then the debugging can be really painful because you do not get any errors, so your pod will not be restarted. What you get is some spikes, some latencies, or it can be some timeouts. Yeah, it's a big difference to memory, because in memory we get the feedback from Kubernetes quite fast that something is wrong with our configuration, right? Oops, yeah. Possibly it's worth to know to mention that I mentioned already that actually you can set limits higher as requests, and it's the same situation for CPU, and it works in this case. So if you would set the limit here in this situation a bit higher, so not 1 CPU, but for example 2 CPU, yeah, you will get then a larger quota. Then at that amount, at that point in time here, when our requested quota is already exceeded, then it depends. If the host node has at exactly this moment idle CPU time, it will give it to us. So in this case, we will have luck and our request will be processed in the expected 40 milliseconds. But it's not guaranteed, so it depends. So if there is idle CPU at that moment, we will be not throttled. If everything, so all applications are on load, then we will be throttled. Okay. Yeah, so, and here's a list of recommendations. Always configure request and limit. Then very important, monitor CPU throttling. So normally in Kubernetes cluster, you have some kind of monitoring, Prometheus, Grafana, whatever. CPU throttling is a metric available. If you have some strange behavior in your application, like spikes of latencies or timeouts, always check CPU throttling. Possibly you have this. And yes. Okay, you raised this
hand. Just to have a short question regarding your example. If you go back to the example diagram, I see that request number 3 is starting almost in the moment when the request number 1 is already finished. Yeah. Even in this case, it will be throttled.
Yeah, because we are talking about quota. We are talking about time we are using CPU. It can be the same CPU core. It can be 2 different CPU cores. So here's this. I assume that these 3 requests are on 3 different threads. But in theory, it can be that request 1 and request 3 are on the same thread and are on the same core. But it will happen the same because it's just counting the time we have used.
Yeah. But my question is a bit another. So as I see in the diagram, the request 1 is already finished and should free the thread and CPU before the request 3 started.
Yeah.
At least as in diagram.
Yeah, so it's actually you can shift it if you want.
Okay. So it's really in parallel. Yeah.
Yeah. So it's really parallel.
Okay.
Because
that's the question.
yeah.
And the second. Second question, would you easily recognize it somehow if I say, for example, describe port? Do I see somewhere in events or somewhere that it's throttled?
No, only in metrics. You get metrics.
Okay.
So it is the case if your pod has been restarted due to memory usage, then it will be restarted. You can get your events and you will see, oh, I am killed. And it's clear indication. Okay, you hit your limit. But with CPU, why CPU throttling is so so bad to debug? It's sometimes called like silent killer, because it's really, if you do not know where to find this metric, it's really hard to explain.
Okay, that's nice to know. Yeah, thanks.
Okay, so exactly this point, this recommendation, benchmark your application. It's clear. So if you're deploying something, it makes sense to make a load test, and it plays together with the last recommendation. So we can set limits higher as request, and I would recommend do so, but I would do it in that way that first set request equals to limit. Yeah, so this guaranteed quality of service, so minimal amount of compute power you are guaranteed to get. Benchmark your application. You show that you can serve request in SLA declared amount of time. And then when you deploy to production, you can increase limits, possibly 50% or possibly twice as higher. It will just give your application a bit of boost. Yeah, it's not guaranteed, but you can benefit from it, and it doesn't cost anything because you pay for the host for the worker node, and so this CPU will be either idle or you will get it for free. Yeah. Okay, let's continue. Let's go further to GVM Ergonomics. So what is GVM Ergonomics? What I mean here is, when you start a GVM, you can actually provide tons of parameters. You can set max heap size, min heap size, your garbage collector, dozens of configuration parameters for a specific garbage collector. But normally we are not doing so. If we are just developing locally or deploying in different environment, I don't care. I just throw my container in Kubernetes and it works. Yeah, and it's exactly what GVM Ergonomics means, because if GVM starts without explicit configuration, it tries to find out itself what amount of heap and what kind of garbage collector is most suitable in this particular runtime environment. And so GVM has been developed many years ago, so started developed. And this GVM Ergonomics, they designed this assumption that GVM is running on some operational system, and in the same operational system, the additional processes running in parallel. Yeah. In Kubernetes, we have a bit different situation. So it's a shared environment as well, but the isolation happens on another level. Yeah. So our containers, so our pods, we can say our pods are isolated each from other. But in a concrete container with our GVM, it's actually only one process we have. It's this GVM process. So we need a bit of memory and a bit of CPU for a kernel, but that's it. Yeah. And what happens if we will deploy an application and let GVM guess the ergonomics, all the parameters? So just so what can happen is we can get a too small heap. We can get not suitable or not the garbage collector we expect to get, and we can have a misconfiguration in thread pool. And I just give you an example. So let's suppose we are deploying a Java application with 2 GB of memory and 1 CPU. What we will get? We will get heap size of approximately 500 megabytes. So another 500 megabytes, actually, it's just wasting there. Because, okay, possibly 50 or 100 will be used by Linux kernel, but that's it. Also, as RAM will be just laying around. And another surprise is we will get a serial GC. And the reason for this is we are setting one CPU. Yes, we know already. So one CPU means not a physical CPU, but a 100 millisecond of CPU cycles time for this scheduler. But GVM does not know it. Yeah. So it will be translated in one CPU of quarter will be translated in one physical CPU for GVM. And GVM think, okay, guys, you have only one physical CPU. Why should I use G1, GC, or another modern garbage collector? Because they are multi-threaded. But if you have only one core, serial GC is a really good choice for you. Regarding thread pools, again, due to the fact that it is translated to active CPUs for GVM, many thread pools are relying on the number of CPUs for initial sizing of thread pool. Yeah. And it can lead that we will have really small thread pools or connection pools or whatever, yeah, because it's, some implementations are relying on this number. Okay, so we can skip this. Yeah, so recommendation. It's recommendation from our production environment. So always define your max heap size. I would recommend, so you can either set it in absolute values, in megabytes if you want, but I would recommend to use this percentage parameter, because in this case you must not always recalculate it if you change your request limits. So our recommendations is 75–80%. So the rest is allocated for systems. So if you have really large heaps, I don't know, 32 gigabytes, you can try with 85, 90. So as always, benchmarking. So 75–80 is robust and safe. Then for small dimension containers, if you have some applications which do not have, which are not CPU intensive, so you run them without any problems with one CPU quota, I would nevertheless recommend to explicitly set the active processor count. It's really good if you know what is the configuration of nodes your Kubernetes cluster has. If you are not sure, you can just set it to 2, for example, and it will increase the level of parallelism in your GVM. And yeah, it will automatically trigger a G1 GC from your Java version, if not serial GC. And actually, yeah, again, I mentioned it explicitly. I would recommend to even if you set this parameter, nevertheless define your garbage collector explicitly. So in this case, you're really sure. Okay, then let's go to the next point in our today's workshop. Is about workload type. Yeah, as I already said, so the pod is the simplest deployment unit. So you can create a pod manifest and deploy your application to Kubernetes in this way, but yeah, nobody uses this because it's simple, but if, for example, your pod has been evicted or crashes, it will not be restarted. Yeah. So it's not what we want. And another drawback is that it's only single pod. If you want to have a list of a set of pods for handling a large amount of load, you cannot do it with single pod deployment. That's where the replica sets come in. So it's really simple abstraction. We are just saying, okay, it's pod template. I would like to have 3 replicas. And if one replica gets killed or crashed, it will be automatically restarted. It already sounds good, but nobody uses it explicitly because what it doesn't provide is functionality like rolling update, auto-scaling, rollbacks, and so forth. And actually, what we are really using in Kubernetes are these 3 types of deployments. It's deployment, and deployment internally uses replica set, then StatefulSet. I will explicitly talk about StatefulSet later, and CronJob. Yeah, it's specific kind of deployment, very similar to Linux CronJob. So you just say, okay, I want that this pod will be executed in specific intervals. Yeah, so now let's take a closer look. What is the difference between deployment and StatefulSet? So what StatefulSet gives you, it's a guarantee about the ordering ordering and uniqueness of pods. So if you will take a look at a deployment, for example, here is a deployment with 2 replicas, you can see they have some random numbers. And sometimes you can read, okay, deployment is suitable for a stateless application. And stateless does not mean that you do not save any data, because you can use an external database for saving your data. It does mean that you can kill any instance and replace it with another one, and everything will work exactly as before. But normally we do not care which instance we are accessing. So normally we just have a Kubernetes service in before. It does a simple round robin load balancing, and that's it. Yeah, so we cannot say, I would like to that my request goes exactly to this instance. So it's not possible with deployments. It's different with replicas or with StatefulSet. They are named always with ordinals, always starting with 0. So I can scale StatefulSet as well. So I can say I would like to have 3 replicas, and they will have ordinals 0, 1, and 2. And as I listed here, so it's internal DNS names. So here, if you want to access a deployment, you can access it only via the name of the service, so not a particular instance. With StatefulSet, you can access really explicitly every instance of your StatefulSet. It is used very often in complex deployments. For example, if you have cluster with primary and secondary, and secondary reads data from primary, like you can deploy a PostgreSQL cluster in Kubernetes, and it's exactly how it works. It uses StatefulSet. But for normal Java developer use cases, I think it's quite a rare use case. Where it can be helpful, it's when you need to process data on a file system, because if you save something in a pod on file system and your pod gets killed, the data is gone as well. With StatefulSet, you can create a persistent volume and you can mount it to a particular pod. And if your stateful pod instance gets restarted, after restart, it gets exactly the same persistent volume with the data attached. So it's already a viable use case for Java application if it's needed. And I would like to highlight 2 special use cases. We are using them in production as well. So sometimes, yeah, okay. So in this case, I need to mention we are talking not about some REST APIs, which are mostly kind of stateless. We have special kind of workloads we have in our Kubernetes cluster. What they are doing, they're synchronizing data from A to B, they're reading some buckets and saving the data in Kafka, stuff like this. Yeah? And sometimes we have resources where we need to have an exclusive access. So they are part of our synchronization processes, which can be distributed across different replicas. But there are some processes where we are accessing a resource where only a single access is possible. And then we have a choice. We can either implement some distributed lock, or we can get some distributed leader election algorithm like Raft, but it's additional complexity. But what we are doing, it's really simple solution. We are just pinning the leader to a specific ordinal of our stateful set. We are just saying, okay, the instance with ordinal 0 is the leader. It does all these exclusive access operations. And then the second use case is very similar. It happened in our case with exactly the same workloads. Then sometimes we have legacy applications, yeah, which have been developed and maintained only with single instance. And so we have a choice: either we need to invest a lot of time and rewrite them to make them kind of split them possibly in several microservices, but it's required times and thoughts. So what we did, we just got it and deployed it as is in Kubernetes. But the problem is, if we will have 2 instances running in parallel, we can get a corruption in our data. Yeah. And here it's really important difference between StatefulSet and deployment. So deployment guarantees you at least one. Yeah. So if you have a deployment, when you say I have only one replica, it says only you get at least one replica. So if you, for example, kill or the pod and it gets restarted, or you're doing a rolling update, it is possible for a short amount of time that two replicas are running parallel. Yeah. And in our case, it was a danger of data corruption. And in singleton or in StatefulSet, we can really implement this singleton application pattern because it implements at most one. So if you say we have a StatefulSet with one replica, it's maximum one replica running. The only drawback is we have some downtime. So if you're doing rollback, it's first tears down the instance, the old instance, and then start the next one. So you have some seconds or minutes of downtime, but it's okay for these workloads. It's important to know. Okay. So next topic is horizontal autoscaling. So it's supported out of the box. In Kubernetes, you can just create a configuration, say, okay, I would like, if I have a load higher than some limit on some metrica, that you still start to create new instances of my deployment, for example. Important to mention, it gets the request, so not the limits, but the request of our resource definition for this. And by default, there are two options. You can scale on CPU and you can scale on memory. It looks like this. Here I'm saying I would like to scale my deployment if we are getting higher than 80% of CPU usage. There are 2 points we need to consider here if we are talking about Java application. So one point is very often Java applications are quite slow in start. And we have experienced French effect that we get a lot, and we see that Autoscaler starts to deploy new instances, and it's not yet ready, but start the next one and the next one and next one, and then sometime later it will be scaled down. But nevertheless, it was a very strange effect. It just gives a lot of pressure on the cluster. And the reason is because the application starts to flow. So Scala created a new instance, waited some time. Oh, guy, you looks like it's very bad. So you need possibly a third one, and starts to create a next one. What will help, you can configure the behavior of Autoscaler. So many people just using default values. So in our case, I just copied from our production. We are saying here, do not create a next pod not earlier than in 60 seconds. So I'm giving 60-second time to let the previous instance to start properly. And then there is this stabilization window seconds parameter. It just gives a longer period of time for scheduler to calculate more precisely this average consumption number. So as always, do the benchmarking. Possibly in your case, these numbers will be another ones, but in our case, it was a good match. A really important point is about autoscaling on memory. If you're using Java older than Java 12, so Java 11, do not use it, because garbage collector allocates memory. Java allocates the memory. Yeah, then a garbage collector is executed, and actually it frees the memory. It's marked. It frees the heap. Yeah, but it does not give the memory back to the operational system. That's the problem. So it will just lead to the situation that you will get a lot of instances created by your autoscaler. So it should be work better with Java 17. We have not tested it, so to be honest, but according to the documentation, it should work now. So next point is pod disruption budget. We talked about a situation like, okay, our application crashes, or it's not pressure, stuff like this. These are kind of unexpected disruption of our services. But there is a second kind of disruption, voluntary disruption. It's, for example, cluster management or node updates, because worker nodes where our workloads are working. Yeah, from time to time, our operation colleagues needs to update the operational system on it. Or in data center, it can be that the hardware, they need to change the hardware to install a newer one, or possibly they have some troubles with hardware. These are voluntary disruptions, so they can be planned, yeah, it can be executed. And the point is, if you would like to deliver a high available service, and you deploy 2 pods of your deployment in Kubernetes, it can happen that they will be scheduled on the same node, yeah. And if this node will be taken for maintenance, it can happen that both pods of your application will be shut down at the same time. So okay, they will be restarted automatically by Kubernetes, but you will get a couple of second downtime. And you can control this behavior by creating a pod disruption budget. It's kind of contract between you and operation guys. So you can just say, it's my application, and depending on how you set the parameters, there are 2 parameters. So you can say either number of allowed disruption, so how many of pods of your deployment can be shut down at once, or another option is you can say a minimal available number of pods. And it is actually a balance between availability of your application and speed of the maintenance. So if you will set min available at 1, you can give more flexibility to operation guys, because you really give the freedom to them to speed up the maintenance process. But if you say max unavailable 1, it means you allow only 1 pod per one to be moved from node to node during migration. Yeah, so it will slow down the process. So you can set it not only to 1, you can set it to any arbitrary number. It's a values we are using, but yeah, keep in mind. And the last topic I would like to share with you is pod Anti Affinity. It's very similar to what I have said before, maintenance, but there is a third kind of disruption we can experience. We can have an outage in data center. Yeah, so we have some physical server, where our virtual machines are running, and it's broken. It doesn't work anymore. Yeah, and it's again the situation. You have your high available deployment with multiple pods, but if you have this, the case that all these pods have been running on exactly this failed node, and you will have a disruption of service. You will be down for some time until Kubernetes will restart your application on different node. You can have influence on it, and this is named pod Anti Affinity. So there is pod affinity, pod Anti Affinity. These are rules. Similar like request are relevant for Kubernetes scheduler and decide on which node it puts your application during deployment. It's exactly the same kind of rules. If you define pod affinity or pod anti-affinity, it's just a hint to the scheduler how it should spread your pods across working nodes. And here's an example where we are saying actually we would have anti-affinity, so we want to spread our deployments on different nodes. And here a really simple rule where we are saying, okay, I have this. So what I want to express here. So if you see a node and there is already an instance of application with this name on it, please try another node. It's really simple. Just like a hint to it, and yeah, so you have then a higher probability than you have if you have an outage of the data center, then at least one of your pods will be run on a node which is not affected by this outage. Yeah, that's the idea. Okay, we are done so far. Now it's time for questions and answers.
Any questions? Any to own experience, perhaps? So until you're thinking, I have 2 small questions. First is more concrete regarding the parameters for Java virtual machine. We have
Yes.
sometimes we create our containers or our images using the plugins, the Google Jeep plugin or Spring Boot plugin that basically encapsulate Java call into the container. Do you know, is this plugins care about such parameters, or it's necessary to customize them as well?
So I have experience with G plugin, and it does not set any Java arguments by default. I suppose you can define it.
You can configure it, definitely. My interested is that some default settings.
The problem is you can define it during the build, but for example, in our case, we have situation where we are using different configuration for development, for staging, and production. Because we want to save some money, and we are running our application with smaller resources in development as in production, because the load difference is huge. So what we are doing, we are setting this with via environment
parameters. Okay, I get it. Yeah, makes sense. Okay. The second question, I heard something about Java 17 that it's be able to recognize somehow is it running in the virtual environment or real environment, and have kind of adaptation on that. Do you know something about that?
Yes, so Java, starting from Java 8 even, so with Java 8 at the beginning it was not aware of containers. So there were a lot of problems with Java 8 running Kubernetes at the beginning because it was not aware I'm running in container or running on a physical node. So in Java 11 they have implemented already some improvements, and they have been backported to Java 11. And with each Java version, they are providing more and more features, which making GVM more cloud native or Kubernetes native. So for example, here I mentioned this issue with memory autoscaling with Java 11, and already in Java 12 they have released this JEP. Is that garbage collector returns unused committed memory back to the operational system, which allows you to use, in theory, the autoscaling based on the memory.
Nice. Okay. And regarding the StatefulSet, I hear a lot of recommendations that normal developers shouldn't use it at all. So it's something for the people who design their databases or distributed caches. They really could work with the StatefulSet, but it's not for normal, let's say, developer of the microservices. Do you have any use cases really where you use the StatefulSet in your practice?
Yeah, so I'm agreeing with the statement that in most of cases you are totally fine with the deployment. But as I mentioned here, sometimes you need to persist data on a volume, on a persisted volume that will be saved between restarts. So we have a special case. We have our Spring Cloud config server. This fetches the configuration from a Git repository, and we want that it caches this configuration even between restarts. Now, for example, persistent caches. So if you put these caches in deployment in normal pod, it will be gone. It will be lost after the restart. So it's So it's not so many use cases where you really want to write to a file system, to a volume, and then have this data after restart. But perhaps there are some.
For caching, it's possible to introduce some Redis server and use it as well as outside of your deployment.
Yeah, right. Because these two special use cases, I would say they are kind of technical debt or specific that these workloads I'm talking about, they have been moved from older applications that were running on dedicated compute instances.
Leader election.
So you can do it in right manner with deployment as well, but it just was the question of time and efforts for the migration.
Okay, thanks. Other questions?
Yeah, I have a few questions as well. So it's regarding the first part of your presentation, that's you arranging some resources to your pods, and like what will gonna happen if like you arrange more memory than you have in real? Like have you tried that?
So you have in real on a node, you mean?
Like on the server, for instance, you have like 8 gigabytes, but you are assign
Yeah.
like 16.
So then you will get an error during deployment or during scheduling actually of your pod. So what will happen? Okay, let's go here. So you put your pod definition or deployment definition in Kubernetes. There is a special controller in control plane. It just monitors. Oh, hey, I have a new application that want to be executed, and it checks what amount of resources you would like to have, and then it tries to find out a node which has corresponding computer power. And that then two choices. If you have statical pool of worker nodes, then you will get this error which will say you, sorry, I cannot schedule your application because I have no nodes which can run your application. In some cluster deployments, you can configure auto provisioning that automatically a new virtual machine will be provisioned and attached to the node pool, and then your deployment will be put there. But it's I would like it to say it's more specific. So more highly likely you will just get an error.
Okay, so it's like on a Kubernetes site. So it's not like performance degradation or some like resource starvation, but it will be an error.
No. So it's exactly. So
Mm-hmm.
if you define requests, why it's important to define requests? Because requests are guaranteed. There is a term of quality of service in Kubernetes, and if you have set requests and limits and to the same value, and you have been scheduled, then your performance is guaranteed by Kubernetes. Yeah, so you will always have this amount of power. Yeah, it's a nice feature.
Okay, and the second question, thank you. And the second question regarding the performance. So like you also said that you gonna like when you set everything and you gonna benchmark it. And is it possible to understand if you allocated more resources than it's needed for this amount of, let's say, limits?
Yes. So actually, it's based on metrics. So you can either analyze your metrics yourself, because you get amount of used CPU, used memory. But there are tools which do it for you. So, for example, there is a Heap cost. So we are using it at Conrad. So it's a special tool. It just collects the metrics and analyze it. And what you just get a report when you see, okay, you are under provisioned or over provisioned, and it can give you some hints. Okay, you can reduce your CPU usage from 4 to 2 because you have analyzed your CPU consumption over 2 weeks, and you have never been over your CPU. Stuff like this. So yes, it's possible with some additional tools.
Yeah, thank you so much. All from my side.
Basically, how many of you already works with the Kubernetes? Do you just raise the hands? Okay, not so much. Perhaps we can also consider to some basic workshop as well, some fundamental understanding of Kubernetes, what is it and how it works. Okay, any other remarks, questions, or wishes?
Yeah, I remember one question, but it's like a more specific one because I was researching about operators in Kubernetes. Have you ever used them or?
Yes.
So you are like doing it in Java or on your
Yeah, so Kubernetes provides a framework and API for developing custom operators. What it does mean? So okay, I will go possibly to again into this. So actually, it's a control plane who does it. So there is a storage where all this resource definition are stored. So it's like a pod definition, deployment definition, but it's not limited only to this standard Kubernetes objects. You can define your own. You can deploy or you can create your schema and create your own YAML and push it to the database. And then you can create an operator which can monitor via the Kubernetes API if an object of desired type has been created or updated or deleted, yeah, and do some action on it. Normally, because what would you need it? Yeah, if it's deployment, you have functionality like running update. It tear down one pod, it creates a new one. But if you have more complex deployment, like for example, a cluster with one primary and one secondary, a running update looks completely different. In this case, before shutting down the primary, you first need to do a fail over to secondary. It's a special process, and then you can tear down your old primary. And that's exactly this logic which Kubernetes does not have. It's what people are normally implementing in custom operators. So there is, for example, a custom operator for PostgreSQL. Mm-hmm. Mostly they are implemented in Go because Kubernetes is implemented in Go. It's de facto standard. But you can do it in Java. There is a Java SDK for it. You can do it in theory in Java. It's possible.
What I also seen for some customers how to use the operators. There are old GE providers like Oracle or IBM for WebSphere also create kind of operators for Kubernetes that the customer can still deploy normal GE web applications, but into Kubernetes. Other question is, is it have a lot of sense? Yeah, but at least for marketing sense, yeah, or for marketing reasons, yeah, they are kind of set it as a new life of GE applications in the Kubernetes cluster. And for customers, it could be some intermediate step before they completely redesign the stuff and migrate into microservice framework, like Spring Boot or other. They can use as operators.
Okay, by the way, if you have a minute free time, I have one more slide. I have skipped it initially, but so you had a question regarding this GVM newer version, if they are better understanding the Kubernetes and container environments. So if you're talking about GVM Ergonomics, so I was a bit surprised, but it was Microsoft who initiated the discussion, and they're proposing, it's at the moment it's really draft. I don't know if you can read it. It's small. Yeah, I will send them a slide with the link. So they are trying to create a JEP proposal that introduce a special profile, and with this profile you will be able to indicate are you running in cloud, in container environment, or are you running in old-fashioned on-premise service. It was interesting to read here some interesting statistic, because they have found out that 70% of monitored GVMs in production are actually running in containers. It's just for understanding. So I suppose it's quite a lot. So I suppose they are talking about GVMs running in Azure, so not all the world, but only the Azure. But it's, I mean, it's already a really high number, I would say.
They only can monitor.
Yeah. Okay.
Okay. So last chance to make a questions or notes or wish. If not, I would say thanks a lot, Andrei, for these interesting aspects. Was very interesting for me especially, because for a lot of things I don't care or don't know that kind of things exist. And for example, especially in this throttling, you just see that application slow down and you don't know why. now at least you have an idea where to look. So thanks a lot for your talk, and thanks also for all participants to hearing it and discussing it. So I stop the recording and see you in the next workshops. Bye bye.
Thank you.
Thank you.
Team.
For the presentation.
Thank you.